So depending on your reference frame, if you're at rest, moving or moving really, really fast, you experience the universe very differently. Do we all get different measurements for the same events? And are we doomed to disagree about reality? Well, interestingly enough, no. There is, in fact, a reality that we can all agree on despite our different experiences and observations. It's important to note that there is one crucial constant that does not change in each observer's frame of reference. That's the laws of physics. The same laws that explain nature's forces, the mechanisms of motions, and the mathematics that describe them is always the same. Even if the numbers in those calculations are different, the rules of nature stay the same. Second of all, recall I mentioned that events, a thing that happens in space and time, are real. Regardless of what time you think they happen, their order of sequence, or the distances in space, it also turns out that the separation between events, something called their space-time interval, is also quite real and absolute in its measurement regardless of what each observer sees. Since it became known that space and time individually were not absolute, and the observations of both were highly dependent on an observer's frame of reference, it was quite natural to start treating space and time together as a single unified entity known as spacetime. It also became natural to define the notion of a distance between events in spacetime that would be preserved and consistent between observers. Many of us are familiar with the regular concepts of distance in a 3D space. Slightly different, spacetime is a 4D construct with 3 dimensions of space and 1 dimension of time in one unified framework. The concept of distance in spacetime, or the spacetime interval, the square of the spacetime interval between events, is equal to the square of the time separation minus the square of the space separation of those events. When you substitute the values of these observed measurements from any observer's reference frame for the same 2 events, you get the exact same spacetime interval. So there's something more real about the spacetime intervals than what we can observe ourselves looking at space and time separately. Now we finally have a basis for reality. One is an event, which is a combination of something happening at a certain time in space, and the other is a space-time interval, which is the distance separating 2 events in space-time. And our observations, which differ between us depending on our frames of reference, can ultimately be reconciled in this new space-time framework.